Hi, I want to talk about some of the tuning things that I do on this Air Arms TX200 Mark III, I believe. Most people talk about tuning these a little bit, and they concentrate on very few things like replacing the spring and stuff. Here's the original TX200 spring. This is a 22 caliber version. If you notice, the front guide has a little bit of slop back and forth where the top hat or front guide sits on front of the spring. This is the OEM spring and OEM guide. There's a lot of slop in the OEM rear guide as well. So I had Jim at Air Rifle Headquarters years and years ago build me some custom guides, and you notice if I push the spring on, they'll go on. It's very tight. There's a front guide in the rear. You can see how it'll fit very tightly. You know, as the spring compresses, it actually grows on the ID, so it has no problem sliding back and forth on that under pressure of the force of a spring. But the tighter guides will have less vibration on a lightly lubed spring. Those are some of the basic things. Other little things I like to do. Again, this is probably around a 2008 version. They didn't secure the barrel or the shroud at the time. This has shroud. I've added some securement as well as the epoxy that goes and it gets the shroud, which is the barrel is inside here. The shroud covers the barrel. It's originally only held on by epoxy here, so you know, over time it could have an issue. So I added the set screws in there, which come flush. You don't see them; they go right underneath here. There's no contact there. Those have to be done on a mill, so you measure precisely how deep you go through the shroud and in the barrel, and not to go into the area of the bore. So that's one thing that was also added. Is the other thing, the OEM foot that secures the action into the stock originally was an aluminum one. Later on, I upgraded it to an Air Rifle Headquarters aluminum one, and then I changed it to an Air Rifle Headquarters stainless steel one. So then you can't have a stronger one than a stainless, I suppose. So you don't have the screws wallowing out with any movement or anything. It's just a much sturdier and stronger version of the shoe, or the you know, the securement into from the action into the front forearm of the stock. Other things. The little sintered metal shoe that comes OEM or on these guns is made from powdered metal in an investment casting process that they basically cast, and it's not. You can see that even the OEM one doesn't fit tightly to the gap or the groove where it's the flat where it fits. It has forward and rearward motion in there. I can move it back and forth, probably 5 to 7 thousandths or better. So the best thing to do is to use one of the custom made out of tool steel. You know, it's machined on a mill and stuff, so it's made out of a tool steel, and it's going to fit much tighter, and it's a much stronger material versus something that was a cast product. Here's the one that goes on this gun. It fits in here, nice and tight. It doesn't have forward. It's also made to have better lockup. So because of the length of it, and in conjunction with the cocking arm, it's going to pull it forward at a little bit more distance than the OEM one, just to get it snug where it belongs. Let's see, a couple other things. A lot of people don't overlook is the inside the barrel. There are two O-ring seals in here. On the bottom one underneath, I have one actually, they're stacked, one on top of the other. I have one of the black ones, and then I have a high heat, one of these clear ones on top actually. So they're deep in that pocket, but they have to be looked at from time to time to make sure that they haven't extruded or heat hasn't melted them, or they haven't compacted down so they're not sealing against the barrel right the way it ought to. This nut should be looked at. It doesn't come loose. It's actually epoxied in, or it's inside it. There's an O-ring that's sealing the nut to the outer sleeve of the compression chamber. Another thing I had done on this one is I had it honed on a Sun and Hone, and that is basically, this is a bore gauge, and it's measured in 10,000. So if I push this up and down in here, you can see on the bore gauge needle that it's very, if I'm moving this back and forth, it'll move. So I have to actually hold it very still vertically, and I can take it and twist it, pull it in and move it out and twist it around, and I can, it's within 10 thousandths. Each of these is 1/1000th, and you know, going this, so that'd be 1, 2, 3, 4, 5, 6, and so on. If it's getting larger or smaller, that's where the needle would go back and forth. But if I'm just moving this around, you'll see it. So you have to have practice and care when you hold this at the same as you pull it in and out. This is measuring the width, or you know, of the bore. So this is something we used at the honing shop, basically to test that we've got it true and there's no taper or high spots and low spots. I took about 10,000ths of an inch out of here, which would be 10 of these units, in order to true it up fully. And it's a hardened sleeve, so it actually is quite hard to hone fully. But most of it was because underneath the area where the flat was, there was a gap almost that you can see, in that I got that completely eliminated by honing it out. Now it takes a seal that doesn't really require any material removed. It still fits fine. If I can see, I can push my finger on the end of it and makes good pressure. This one is just fitting just perfectly. So, and it's true from top to bottom, and the complete circumference has been honed. And just something that I do a lot on all the guns that I've tuned over the years is a Sun and honing the compression chamber. A couple other little things I've done to this one. I make it so that there isn't any slop in where the cocking arm connects to this part here. I make up little sleeve. Basically, you can see it here. Let me get this off there. The grease is holding it to the cardboard. Here's one, and then there's one on the other side. You can see that there. One goes on each side of this, and the pin, then it's hard to get this in with the grease and all, and to move those in, almost like a Vyrock barrel breech, that you have to get those sleeves, you know, shims inside there. But they keep it from having any side to slide, rattle, and play when you cock the cocking arm, versus trying to, you know, fit buttons or do something like that on this particular part. So, you know, shimming that up would just keep it so it's nice and you know, be able to put some grease on it, put those shims in it. It's nice and tight and it's smooth when you cock that. Again, those are just some of the finer points. I also like to add in some shims in front of the compression chamber in this part in here. Glue these down and in, and basically that you have to play with how many thousands you need, but when the compression chamber is all the way forward, there isn't any gap. That it comes in, it sits on that shelf, and it basically can't be slammed forward and causing forward and reverse movement that imparts a lot of forces in the entire cocking train and rifle. So having it come to a solid stop on the shims, you know, you have to kind of work up to where it needs to be with the gun. I like to find the distance you need without the gun assembled with all the spring and everything in it. So, you know, it takes a little bit of time to figure all the geometry of everything, but having the cocking shoe machine tight here, having it where it fits this tightly there, then there's not any forward and reverse movement of the cocking. I mean, throughout cocking or throughout the firing mainly. So if when the piston fires and it comes forward, it just rams this forward. Otherwise, if there's a gap, it basically causes the seals in there to continue to extrude and just get pounded into the barrel. By having them get completely closed and be closed up, it's not going to have that where it's getting pushed in and out each time it goes through a firing cycle.